Whilst modern diesel engines offer low fuel consumption, they also suffer from relatively high particulates and nitrous oxide emissions. Current four-stroke gasoline engines can offer lower emissions to diesel engines, but at an increased level of fuel consumption. A five-stroke gasoline engine offers the best of both worlds: similar levels of fuel efficiency as a diesel and emissions levels that are comparable or better than the best four-stroke GDI engines. In addition, the five-stroke engine offers a high specific performance rating that can also be realised in reduced size and weight when compared to a current four-stroke gasoline engine. The five-stroke concept was invented by the Belgian inventor Gerhard Schmitz, and Ilmor has now proven the theoretical benefits with a 700cc turbocharged three-cylinder prototype engine. This engine produces 130 brake horsepower, equivalent to 185 horsepower per litre, more than 160 Nm of torque, and yet only consumes just over 220 grams per kilowatt hour of fuel. The five-stroke concept utilises two fired high-pressure cylinders operating on a conventional four-stroke cycle, which alternatively exhaust into a central expansion low-pressure cylinder. This low-pressure cylinder harnesses additional work from the expanding exhaust gases, which is discharged directly to the exhaust system in a conventional four-stroke diesel or gasoline engine. By utilising a low-pressure cylinder, an optimum expansion ratio can be selected independently of the compression ratio. The additional expansion and extraction of work from the exhaust gases results in a lower exhaust temperature. This in turn reduces thermal loading on exhaust components and eliminates any requirement for cooling via overfueling at high power ratings, and this of course significantly improves real-world fuel economy. The principal benefits of a five-stroke gasoline engine are: increased thermodynamic efficiency due to the extra work gained by harnessing more exhaust gas energy, a large overall expansion ratio approaching that of a diesel engine but with gasoline fuel, minimised pumping work due to the downsizing effect from highly rated cylinders, a high rating yet small compact size, up to 20% lighter than existing production engines of a similar rating, lower exhaust temperatures, therefore improved thermal management in vehicle and increased flexibility for exhaust system specification. For example, variable geometry turbochargers can be used. Employs current manufacturing technology, so no unique or expensive manufacturing process is required. A range of additional refinements and enhancements are planned which will further improve the low-load fuel consumption, such as twin inlet valves to provide four-valve charge motion, a switchable exhaust valve direct to turbo to improve light load efficiency, direct injection to improve combustion efficiency and to allow an increase in compression ratio. Having proved the five-stroke concept with a prototype engine, Ilmor is currently discussing options with several OEMs and investors to jointly develop the second-generation engine for in-vehicle testing. This second-generation engine will offer a brake-specific fuel consumption of 215 grams per kilowatt-hour, or 10% improvement on current four-stroke technology. It'll feature smaller packaging, being 20% lighter than the current prototype engine and offering a power density of at least 150 brake horsepower per litre. As well as the obvious automotive applications, the five-stroke engine would be ideal for integration into a next-generation serial hybrid powertrain or for stationary power generation applications such as combined heat and power. For any further information, please contact Ilmor Engineering Limited via www.ilmor.co.uk.